All right, in this video I'm going to introduce how to do more complex calculations, conditional probabilities, and pivot tables. So what we're going to do here is we're going to start with the problem prompted from the class notes, where we've got two events and a data set here that indicates whether or not a unique ID for each purchase that transpired in our store, what color of shirt, and how much was spent. And we're going to define two events here. A, meaning a red shirt was purchased, and B, meaning $25 was spent. And we're going to be interested in calculating a lot of different probabilities. Now, in the last video, I showed you how to use the COUNTIF function in order to calculate probabilities. And we could do that same thing here. So how would we calculate the probability of event A occurring, that is, of a red shirt? Well, we could simply say how many red shirts are there and divide that by the number of purchasers we've observed. Okay? So we can do this very simply. I can say COUNTIF $A to $A, $B to $B. If anybody in column B matches the criteria red, count it. Now this is currently listed in a percent, and that's my mistake. I'll change that right now for simplicity. We'll see that there are 282 of those individuals here. Now, to turn this into a probability, we need to divide this by the number of observations in our data set, which we can get as the max of our observation number, or our purchase ID number. Okay? So with this, we'll know that it's 0.18, or an 18.8% chance of observing a red shirt purchased. Great. Now, we could go through this for each one of these events, but there's a much simpler way to do it. What I'm going to introduce to you now is called a pivot table, and so I'd like you to go to Insert and select Pivot Table. It's going to ask you for a data range, and for this we need to select all of the data we're interested in describing. Now, pivot tables are a quick way of summarizing data very quickly along multiple dimensions. So what we're going to want to do here is click in cell A1 and highlight all of our data. Once our data is highlighted, we're going to want to put this somewhere that's easy for us to work with and still in view of all the data. And so I'm going to put this in cell M1. All right. Now, right now, this looks like a blank form, and it in fact is, but what we've got here is a pivot table tools setup, where we're going to be able to drag our variables, our column headers, into either rows, columns, or values as a way of describing them. So let's go ahead and see if we can replicate our number of red shirts in a quick way. I'm going to drag the word color into rows, and what we'll see right away is by doing this, Excel is going to come up with a unique set of colors and put one of them in a unique row in our pivot table. Okay, so instead of going through and sorting this data and looking for all the unique values, if we just put them in a pivot table, it'll summarize that for us. The next thing we can do is drag color over into values. And under values here, it'll give us the count of that color. So for example, we see that there are 282 red shirts. Well, we found that before when we did this with a COUNTIF function. Since we know there are 1,500 total observations in this data set, we can just simply say we want to take N6 and divide it by N7, which is how many red shirts did you see, divided by how many observations do you have, or 0.188, or 18.0%. It's the same thing we got if we would have used a COUNTIF statement. We'll just click back in our pivot table here. Once we have our pivot table selected, we can go ahead and drag the word spent into columns. Now, this is a two-way frequency distribution. This shows for two different variables how likely are each of those things to occur. So for example, we know that there were 282 red shirts purchased, but we can now say how many of those red shirts cost $10, how many of those red shirts cost $25, how many cost $42. We can also say, for event B, how many times was a $25 shirt purchased? Well, it was 684. So if we want to calculate event B, we can say this is P8 divided by S8. 45% of the time, customers are only spending $25. The probability of A and B, well, we can say, where do we see A occurring? Where do we see B occurring? Well, the intersection of those two is this 127 out of the 1,500 total. So we can say that this is going to be equals P7 divided by S8, or 8.47. Now to calculate the probability of A or B, all we need to do is follow our rules on the slides, which tell us when we see the word or, we take the probability of A, add the probability of B, and subtract the probability that both occur simultaneously. So we can, having already calculated those values, we can say this is simply E2 plus F2 minus G2. We'll find out that of all of the possible outcomes, almost 56% of the people either purchase a red shirt, spend only $25, or both. Now, the probability of A given B in this example is the probability of seeing a red shirt purchased given that they spent $25. So we are saying, given that we know someone spends $25, and there are 684 people who do, what share of them buy a red shirt? Well, this is actually a much easier question than it seems. This is just P7 divided by P8. The number of people who bought a red shirt that was $25 out of the total $25 shirt buyers. Lastly, the probability of B given A is the probability of somebody buying a $25 shirt given that it was red. Well, this is just saying, of the 282 people who bought a red shirt, what share bought one that cost $25? And so again, this is going to be P7 divided by S7. Okay? Given that you bought a red shirt, there's a 45% chance that you spent $25. All right, I hope you can see how both pivot tables and count if and if statements can be useful in their own settings.